Oh, it's asking a meeting ID for the current session. Okay. Why? Okay, 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 1 minute. There is an issue apparently with the link. So I'm going to send a new one.
So we have to join again?
No, it's okay.
Okay.
Just for the students. Okay. Okay, so I've updated the new link, so people might take some time to join.
Yeah.
Sorry about that. Yeah, there was an issue with the link on the calendar.
No
Usually we
worries.
should expect around 20 people, so we can wait a few minutes.
Yeah. So also the people there in Lisbon are following it from their computer.
Yes,
It's not like in Portugal that you were there.
I mean actually they're just here, but like I have this little
Yeah,
setup to
yeah.
Okay, yeah, people are joining, so I guess okay. Hey, hello. Hello guys. Yeah, sorry about the link. Okay, so this is a special session. We have two guests, Massimo and Luca. I've met them at the first bootcamp in Porto, and now they are building on the IC. I think it's the first external contribution to the protocol, so it's cool what you guys are doing. And you originally built Omnia, which was a way for a canister to control a physical object or to connect to a physical object. And now you're building WebSocket on the internet computer. And you're probably going to explain that way better than I could. So yeah, maybe we can start with how you got involved with this and what led you to build Omnia and then the transition to WebSocket. And if you need, you can share your screen at any point. Yeah, it's enabled now. So
yeah, sounds good. I guess for now we can just talk a little bit and then we can go more into details. But basically, we've been working on Omnia for 3 or 4 years, and this was like 3 or 4 years in which we really explored the IoT space, so the Internet of Things. We were really interested in devices that could sense, but also act upon the physical environment. And we were playing around for a long time with different devices, and we started noticing that it was really difficult for devices that are not from the same manufacturer or are not part of the same platform, like Google Home or Alexa or whatever other platform, to interact. And so we said, okay, let's see if we can do something about it. And we realized that there was a need for basically a way to unify the interactions among all these devices, which right now we're already familiar with these devices. They are everything from like the smart plug to the smart light to the smart door lock, all these kind of things, or all kinds of sensors, of course. But we believe in the future there's going to be literally trillions of these devices spread all over the places. So in the fabric of our clothes, in any object that we that we touch, and so there's going to be a need to basically break the silos which contain the data from the different manufacturers or from the different kinds of devices, so that we can make the most out of this data. And we saw that there was no protocol or no unifying standard that allowed all this data to be shared across devices, and especially applications that might need that data to didn't have a way to access it. And we started thinking how we could solve that. And I mean, one way of solving it, of course, would be to force all the manufacturers in the world, all the manufacturers of IoT devices in the world, to adopt our standard, whatever that is. But that was not possible, right? Because I mean, it's an ongoing battle between manufacturers of who dictates the standard, and there are different standards because every manufacturer wants to dictate their own. And we definitely were not in a better position to basically impose our standard. We were nobody. Like we were not device manufacturers. We were not a global consortium like the W3C or something like that could somehow impose a standard. So that was not a viable option. And so we started thinking, okay, but maybe having one standard is against the interests of the manufacturers, because they want to keep control on their data. They don't want to share it. So maybe it's not in their interest, but it's in people's interest to have like an open or like a layer which enables all this data to be easily accessed by the devices that need it or by the applications that need it. And so we started thinking, okay, let's start from the people instead of from the manufacturers, and let's give people a way to open up their devices so that others can benefit from the data that they measure. And that's how we started exploring the blockchain space, because we believe that's it's a great way to incentivizing people and coordinating people to do something specific. In our case, was making their IoT devices accessible to others, and that's how we got in the space.
That's interesting. I think it's very rare to talk with people that basically were working on something not related to blockchain or Web3, and then you transition because you saw that essentially what you needed, like your problem, could be solved with blockchain, and not the other way around, which is like most of the industry of blockchain. Like, we want to use this blockchain, we don't know exactly why, and let's try to figure out the use case. So yeah, it's super interesting. You have like opposite kind of story. Do you have some links or projects that you could share? I saw that Luca, you shared something, but
Yeah.
unfortunately, you
also-
shared to host and panelists. You have to
Sorry.
send to everyone.
But
Oh, yeah.
we only have host and panelists as an
exactly.
option.
We don't have.
Oh, you only have. Okay, that's my mistake. So, okay, that's good now.
Okay.
Could be chat with everyone.
And yeah, I'm gonna share here also the proof of concept of the project that we did on the internet computer regarding this. So like a way of managing the devices that were connected to this infrastructure on the internet computer, and it's this one. Was called Omnia Backend, and was written in Rust. You can find there also some code in which we were doing the HTTP out calls. So yeah, if
That's
you're
perfect.
interested, I can give you the link directly to the code. But we were basically doing HTTP out calls to the devices in order to interact with them. So for example, turning on and off a light. There is also a demo on YouTube. I'm gonna also send that one, in which we show from a demo application that we changed the color of two lights that were in our room during the demo. So I'm gonna also send that one.
Yeah, so in that case, the application was definitely not the interesting part. The interesting part was really the backend infrastructure that allowed to discover the devices and interact with these devices directly from a canister. So the way it worked, there was a canister hosted on the internet computer, and then a bunch of gateways. These gateways, you can imagine them as like little computers, like Raspberry Pis, that were actually connected to the different IoT devices. So let's imagine there was a gateway for this room, which would connect the light, the temperature sensor, and whatever other device might be in this room to the internet computer. So it would register it in our platform. And then all these devices would be accessible by other applications that we would use the canister that we deployed on the internet computer in order to discover the devices. So let's say an application wanted to turn on the light in this room, it would go to our canister and says, and ask, I need the light of the, I need the unique identifier of the light in this room. And the canister would reply with that identifier, and then the canister of the application that, for example, turns on or off the light would send an HTTP out call directly to the light, which would turn on or turn off. That's what we did in that little demo that Luke is gonna send on YouTube.
So actually, this morning we talk about HTTP out calls. So for those of you that were here this morning, this is kind of a demo of what this feature can be used for.
Yeah, so in this case, the gateways were basically the ones exposing the devices. So the HTTP out call would go to the gateway, and then the gateway would relay to the different lights or the different devices that were connected to it via the specific protocol. Because again, there is no one single protocol yet, which all the devices use. And therefore, the gateway would basically bridge all the existing IoT protocols with, in this case, the HTTP out call feature of the internet computer.
Yeah, and yeah, you can see here in the demo that Seb is showing. On the top left, you see the live streaming. We use YouTube just to keep things simple and quick. And so you were able to select the light and select the color of the light. And after a few seconds, there was a queue of comments. And then when you saw the when you see the HTTPS out call text, it means that the canister is doing the HTTP call to the gateway, and the gateway is then sending the command to the light. So basically, it's a canister controlling these two lights. And
Yeah.
And here I think is where the idea of doing the IC WebSocket started jumping into our minds, because I mean, of course, what HTTP outcalls do is basically they enable canisters to send messages or like HTTP requests to the outside world, and that's great. That means you can interact with any server on the traditional internet, or for now any server with an IPv6 address, but that's detail. The problem with this is that our computers, like the computers that we that we use to interact with the different servers, don't have a public IPv6 address, and therefore you cannot use HTTP outcalls to, for example, send a notification from your or an update of any kind from your canister to the front end of the canister that you're running on the browser. And we actually needed these kind of things for Omnia, and that's why we realized that we needed like some kind of WebSocket protocol on the internet computer. What people were doing before in order to solve this problem was basically polling from each front end. So each client would periodically send a query call to the internet computer, which would retrieve the latest messages that the canister wanted to send to that client. But I mean, that works for sure. There are some disadvantages. The first one is that all applications have to basically recreate this logic, which is it's not like hard by itself, but it just doesn't make sense to recreate something over and over when you can have like the WebSocket interface, which was designed exactly to solve this problem. But even worse, you would have, I don't know, let's say that your canister DApp became super popular, so you have 1 million clients connected to your DApp at a given time. You would have 1 million clients polling once every second, or even 10 seconds, depends how reactive you want it to be. Let's say once every second. That would overload the internet computer of queries, and therefore it's just
for sure
that is just something that it's not possible to do. I mean, it works fine when your DApp has 10 users, but it doesn't work when your DApp has millions of users. And I mean, right now there are no DApps with millions of users, but the goal is to get there, right? So we want to prepare the infrastructure so that the internet computer is ready to serve all these people.
For instance, the Motoko Bootcamp dashboard. So whenever someone completes a project, there is a notification. I'm guilty. I'm pulling the canister. So every second, the front end will pull the canister query. And of course, I don't have any problem. We have, I think right now, 75 students on the dashboard. So it's relatively light. But yeah, that's a really good point, that it's not as scalable.
That's not your fault, Seb. Later, Luca will show you how to integrate IC WebSockets.
Yeah, I'll do. Could you explain to all of us quickly what is WebSockets and how did you guys integrate it? What was the first proof of concept? If you can share something, maybe I can also share my screen. If we have like I know you guys wrote some articles.
Yes.
Maybe I can share this one.
Yes.
If that helps, like this one.
Yes.
Yeah, I think maybe our audience would benefit from a quick reminder of like what is WebSocket and how it's used in traditional Web 2. And then we can dive into the implementation.
Yes, exactly. Yeah, WebSocket is nothing specific of the internet computer. Of course, it's a protocol that is used to send messages in two ways. So it's a bidirectional communication, which enables, of course, the client to send a message to the server, but also the server to asynchronously. So at any time the connection is open, send a message to the client. And this is basically like solves one of the problems that HTTP has, which is HTTP is a request response protocol. So the server can send a message to the client only as a response to a client request, which means that, again, in case the server wants to tell something to the client, it has to first receive a request from the client. And that's why, in order to solve this problem, people do polling, because this way, every once in a while, the client sends a fake request saying, are there any updates for me? And then the server can finally respond with the updates. I see WebSockets, WebSockets in general creates a connection which allows these messages to be sent at any time from both sides. So this is basically WebSocket in a nutshell, in general, not specific to the internet computer. But this is also the kind of like from the outside, that is exactly what it feels like when you use IC WebSockets. Of course, if you go into the detail, you figure out that there is not an actual channel to the internet computer, and we can discuss the reason why, but it's due to the replicated nature of the internet computer. So basically, in order to have a channel, you have to have like two endpoints that you can create the channel with. But in the case of the internet computer, you don't have just two endpoints. You have the client on one side, but on the other side, you have many nodes that make up the subnet and that keep the state of the canister. So it maybe could be done also by opening a specific channel to each node in the subnet, but it's something that would require a really deep integration into the internet computer, and for now is just not really practical to do. So what we did instead, as a V1, we created this gateway, which we called WebSocket, IC WebSocket Gateway, which is a little server that basically on one side offers a WebSocket server interface, which clients can connect to. And on the other side, it pulls the canisters that are specified by the clients in order to get updates from them. So at the end, it's exactly what a client would do, but done in a server which would whose only job is doing this. And also this enables the gateway to poll much more often, because instead of having a million clients polling every 1 second, you can have one single gateway polling every 10 milliseconds or whatever you want to poll, and the amount of queries that the canister would get is still much less. So this is a simple way to basically scale the amount of clients that can receive updates from the IC.
And I guess the main difference is that this can push directly to the client, whereas with the canister approach, the canister cannot directly push to the client.
Exactly. I mean, that's what I was saying. Like if you use just IC WebSocket, the library from the outside, to you, it just to the client, it really seems, and to the canister also, it really seems like you're using a normal WebSocket connection. So you just do WebSocket send from either the client and or the canister, and the other party simply receives the message. Of course, what's going on under the hood is a little more complicated, but it's irrelevant from the point of view of a user that simply wants to send updates from one canister to a client, or vice versa.
Okay, and you have different pieces of software. So I guess this is the main one. So the WebSocket, the gateway, this is the server we're mentioning.
Yeah.
And then you have SDKs. So
yeah, exactly. Yeah, then you have the SDKs, which are what the developers should care the most of. Because right now there is a gateway that we host for projects on the IC. So you, as a developer, you just have to care about installing the SDKs and running the logic on the client. So could be the browser and your canister, which could be written in Rust or Motoko. So we can, for example, we can do a quick walkthrough on how you can interact with WebSockets. And
do you want to share your screen for that?
Yeah.
Okay. Yeah.
Let me share the screen. Okay. Can you see it?
Yes.
Okay. So yeah, basically, what you have to do is that let's start from the front end. So on the front end, what you have to do is that you can install our library, IC WebSocket.js, and what you do is that you simply import the class IC WebSocket. And for those of you who are familiar with WebSockets, you should already be familiar with this class, because the first two parameters are exactly the same as a normal WebSocket on the browser. So you say the gateway, so the server, the WebSocket server to which you want to connect to. The second parameter is a parameter that you can use, but usually it doesn't. You don't need it. And then you have to specify some other parameters that you normally don't specify in a normal WebSocket, which are IC specific. And as you can imagine, what you have to specify is almost the same as the HTTP agent or the JavaScript agent of the internet computer. So basically, you specify the canister you want to connect to, the network you want to connect to, so being it the mainnet or the local network or whatever, and then you specify the identity of the user that is interacting with the canister. Of course, you can also do an anonymous interaction, which is technically not anonymous because you use an identity, but you can use a random identity so that you don't have to make the user login with their internet identity. And then as soon as you have initialized the class, the IC WebSocket class, you can simply declare the callbacks. So when a connection is opened, you declare your logic on the onOpen. When you receive a message, you declare the logic in the onMessage, and so on. So for onClose and onError. And then at some point, like you would do in a normal WebSocket application, Web2 application, you want to send a message to the canister, to your canister, and you just use ws.send, so the send method of a traditional WebSocket. Under the hood, we take care of sending everything to the gateway, and the gateway takes care of sending the messages to the canister, and vice versa. So the gateway polls the canister and gives you the message, the messages in the onMessage callback. And then what you have to do is that you have to initialize it on the backend. So the code here is a bit more complicated, but just because there are more things few more things to do. So let me maybe open it more. Okay, so what you have to do, as you can see, you can install, you can import our Motoko library. So this is a Motoko example. You can import our Motoko CDK. It's it's published on MOPS, so the Motoko package manager. So you can simply do MOPS add IC WebSocket CDK and it will install it. And then you have to initialize some things. What you should care here in this example are the 3 callbacks. So as you can see on the left, you have the on open, on message, on close. And these are the callbacks that are triggered when there is one of these events. So when a client opens a connection, you get the on open callback is fired. The on message callback is called when a client sends a message, and the on close when a client closes the connection. Then you have to initialize some parameters, and as you can see, always on the left, the last line is where you initialize the WebSocket library. So again, for those of you who are familiar with WebSockets, it should be similar to what you are already doing in your Web2 applications. Then, of course, the canister needs to expose some methods, because these methods are needed by the gateway to interact with the canister. And the methods are, again, simply the WebSocket methods. So you have let's go on the right here. You have the WS open method, WS close, WS message, which, as you can imagine, are the methods for the 3 events. And then last method, which you don't have in a normal WebSocket application, is the WS get messages, which, as you can see, is a query method in which, so it's the endpoint, it's the method that the gateway keeps polling to get the new messages to be sent to the clients. And of course, as you would do in a normal WebSocket application, at some point you want to send a message to your clients, and what you do is you simply use the WS send method. So as you can see on the right bottom of the screen, I can also show you a super quick demo. So this is a demo deployed on the internet computer. So the front end you're seeing is in a canister, and there is also the backend canister that is running the logic. What we do here is that we simply have a ping pong application between the backend and the front end. So yeah, just basically what happens is that the front end sends a ping and the backend responds with a pong. Here you see ping ping. There is a typo somewhere in the code, but so it's basically message like a normal ping pong example for
yeah, but sorry, it's the opposite. The backend sends the ping.
It depends where you start. So
but the important part is that here the ping pong is not a response to the client request, but it can be initiated by the backend at any point. So this is actually like not the perfect example, because this could be, of course, be done with HTTP super easily, but it's cool because you can actually start it from the backend. At any time you can send a message. Then, of course, in this case, the client is replying right away, but it doesn't have to, right? It can be like it's just a connection that you can use to send messages in one way or the other at any time. It's not request response. It's not first one, then the other. It's not alternated. You can do whatever you want. You need to send a message, send it.
Yeah.
And of all the things that Luca was showing before, most of it is boilerplate. So most of the stuff of the code that you saw there, it's really just some things that you have to copy and paste, and you can forget about them. There are just the callbacks, which is where you can define your business logic when there is an open connection, when there is a message, when a connection is closed. And so that's where you define exactly what your application should do. But besides that, everything else is really just copying and pasting from the tutorial that we sent on the on the chat.
That's super cool. What's the next step for you guys? Like, I guess you don't want to run this server forever because right now it's relying on you. So
that's exactly
which parts? How will you integrate that with the protocol moving forward? If there is a use case, I guess people are waiting for it.
Yeah, I was actually hoping for one of the participants to basically open the microphone and shout like, "What the fuck? You're putting a gateway between me and the internet computer? How is that in line with like the whole internet
decentralization
computer?"
Yeah.
So that's exactly what we're solving next. Of course, right now, the code for the IC WebSocket gateway is open source, and anybody can copy and deploy their own IC WebSocket gateway, which like somehow enables them to not having to trust somebody else. But that's not really the point. Like, we want to offer it as a service that anybody can simply use, like any developer can simply use without relying on us. And that's why now we are starting to think how we can decentralize this component. And one important thing that I want to remark is that this cannot really be decentralized by putting it inside the IC. There are a few technical reasons for this, but there are many other ways to decentralize it. And so one thing that we're considering now is basically to offer a similar service to the Amazon EC2 instances. So basically servers that you can rent, with the difference that these servers are not controlled by Amazon or any other particular provider. So they are provided by independent parties in the same way that the replicas of the internet computer are provided by independent parties. And also, like most interesting for developers, you don't need a credit card to pay for these instances. You can simply pay with ICP. So this would enable canisters or developers to pay in ICP also for all the computing services that are done off-chain, like, for example, the WebSocket gateway. But even more interestingly, for canisters that are controlled by a DAO, to be able to automatically pay for the services that do, I don't know, notification, or in the case of games, like the multiplayer game servers that are normally not hosted on the IC because you need really low latency. So for all these components that cannot currently be hosted on the IC, we want to develop an infrastructure which of non-replicated instances. So basically servers that you can rent. They're not owned by AWS, so you're not using a cloud provider, which means that if a provider of an instance decides to block you, you can simply switch to another instance. And this is what our protocol is going to do, so that the developers don't have to think about it. They can literally just send ICP to an address and have their instance with their code deployed. So this we're doing, of course, for the WebSocket gateway, so that anybody can like automatically spin up their WebSocket gateway on one of these instances. But we're also planning to offer it as a service that anybody can use to host whatever logic they want to host off-chain.
So if I remember correctly, you have a proposal, right? That you made.
Yeah, I sent you the link, Seb.
Okay.
Just still sending the WebSocket links. I will send you the other link for the proposal.
Yes, there is a proposal on the forum. It's a really, really high-level proposal, so it's not technical by any means.
This one.
Yes, exactly. We don't discuss how we are gonna do it. This is really to get feedback from the community as early as possible, even before starting it, because we know that it could be a controversial topic, because I mean, the internet computer has limitations, of course, but then if you simply move everything off chain, then what's the point, right? So this should really be designed in a way that makes sense, not only for performances, like not only for optimizing performances, but also taking into account where we come from, like what's the general goal of the internet computer.
Yeah. And so yesterday we were talking with OpenChat, and indeed they have a few like off-chain services that essentially OpenChat Labs is paying, and not OpenChat the DAO. So yeah, if they were to disappear or not paying at some point, those services would disappear. So I guess if we can solve that already, that would be good progress for those DAOs. Yeah.
Yeah, so this is what we recently started working on. We would like to get anybody into this conversation. So in case somebody has some ideas, please feel free to share it on the forum, and we will see what we can do.
Sending the link right now in the chat. So the last one is the link to this proposal that Seb is showing now.
Yeah.
And sorry, guys, there is a new guest in here that we're sharing. So in case you hear some noise, that's why.
Yeah, that's true. That like we still have a lot of way to go before like those kind of functionalities are integrated in the IC. We still have many notification services, game servers. Yeah, there is no way to run like real-time server on the IC. So definitely.
Yeah,
I need to take
with this, we don't want to be an alternative to the IC, of course. Like what can be done on chain should be done on chain. You don't have to develop it on these instances to make it faster or like to reduce costs or whatever. Like anything that can be done on chain should be done on chain. This is for everything else that cannot be currently done on chain, to basically not do it on AWS, but do it on something that is slightly better, and you can pay with tokens and not relying on somebody's credit card.
Yeah. And for the WebSocket implementation, are you planning to have them added into the boundary nodes or something like this? Or
yeah,
will it be?
So I don't know if people are updated with the goals of the boundary nodes, but basically the boundary node right now is composed of two components: the HTTP gateway, which is basically the same thing as our WebSocket gateway, but for HTTP, and the API boundary node, which is the real boundary node that interacts with the replicas of a subnet. Dfinity right now is working on taking the two things apart so that the API boundary node will be controlled by the NNS and therefore become part of the internet computer, will run on the same hardware as the normal replicas that host the internet computer protocol. And this will really be on-chain. But the goal, instead, the HTTP gateway will not be part of the internet computer, or like will not be controlled by the NNS. And therefore, what Dfinity is planning to do is basically enable anybody to run their own HTTP gateway, or just access somebody else's gateway in case they want to. And this is where we think what we're doing right now could really deliver value, because that means that, of course, not all developers will run their own HTTP gateway, because developers simply want to focus on their application and not on the IT
infrastructure. Yeah,
exactly. and therefore developers will always have to rely on somebody else to host these gateways. Of course, Dfinity will host one or multiple. Many other major developers or like companies behind the major dApps are also gonna host them. But still, you're like relying on somebody else's for this service, and you have a way to switching from one to the other in case things go wrong, but it's not into the protocol. Like it's something that you would have to manually do. So what we actually want to do with these instances that we are developing now is to basically enable you to switch from one to another super easily without you even noticing it, so that this becomes less of a concern.
Great. Yeah. Huge fan of what you guys are doing. So I'll put the link, and yes, I will add all the links in the recording. This is gonna be posted on the YouTube playlist. And so boundary nodes roadmap. Quick reminder, there is a chapter 13 which talk a bit about boundary nodes, and this topic essentially is a post from Dfinity that explains what's the direction for the boundary nodes, because right now they are only run by Dfinity, but this is only temporary. The goal is to have everyone be able to run those boundary nodes, which gives access to the IC. And you will be rewarded for that, I guess, for the
API boundary nodes.
For the API boundary nodes, but not necessarily the
API
others.
boundary nodes. The API boundary nodes will be run into the normal replicas, so the servers that make up the Internet Computer Protocol, and therefore they will be rewarded by the NNS. One cool thing that we're thinking about right now is that there are so many replicas that are currently not part of any subnet. So basically the providers are being rewarded, but they are not really delivering value. I mean, of course, they're there because the plan is to grow the Internet Computer and also make use of those servers. But all these servers could actually act as the non-replicated instances of our protocol. So not be there doing nothing and being rewarded by the NNS, but being rewarded by a different protocol that we're creating, which enables them to basically host all these other services that are currently hosted on AWS, but that most dApps need. So HTTP gateway, WebSocket gateway, multiplayer, game servers, notification services, whatever an app might need.
Cool. Super cool. Do you guys want to add something? I think we had a few questions. I saw one question. Can this be used as a type of push notification? I think he was referring to WebSocket.
Yeah, exactly. So it can be used not in the strict meaning of push notifications. So you cannot send directly push notifications to smartphones, because for that you need anyway to rely on Google's or Apple's services. But of course, what you can do is that if you have the front end of your application open, so if the user has the front end of your application open, you can send updates to the user without the user having to ask for updates, because you have this WebSocket connection. So let's say you have a wallet application in which you want to send updates regarding the state of transactions, or if you receive new funds while you are on the application, and that you could do with WebSockets. So that the canister could send an update, for example, if the transaction was successful, or if you received a new payment or anything else. and you can see it directly on the UI on the front end, so that the user can already benefit from this type of notifications. And of course, another type of notification that you would normally don't think of is a chat message. So you are on a chat and you would like to be notified when the other person you are talking with sends you a message, right? And in this way, you can do it with WebSockets, because the person one sends a message to the canister, and then the canister can send you a message via WebSocket to you, which you can then receive messages from the canister. So those are all types of things that you can do with WebSockets, basically, and probably even more. These are just the examples that we thought of when we started working on it. And there is also an example, Motoko chat application example that uses WebSockets, and it's I will send you the link also, and it's done by Enoch, who's a guy working right now. He's involved in the ICP hub in South Africa. So he helped us a lot in creating the Motoko examples. So big thanks to him also. I don't know if he's listening, but yeah, we often have chats with him. So yeah.
I see another interesting question related to Vetkeys, or not question, comment related to Vetkeys. That's exactly right. So I didn't mention it, but right now, even if the gateway is actually a middleman, so it basically relays all the communication between the client and the canister, and also vice versa, of course. The gateway right now cannot really do much in terms of attacks. So the gateway cannot tamper with messages. Therefore, the applications, when the application or the canister receives a message, the CDK automatically controls that the message was not tampered with. And this is possible because the messages from the client, of course, are signed with the identity of the client or the user using the client, and the messages from the internet computer are certified. So it's possible to verify that the gateway didn't tamper with messages. But not only that, the gateway also cannot reorder messages, and it cannot even block them. So, or I mean, it could block them, of course, but you would, the CDK and SDK would detect that. So in case one of these things happened, the SDK would tell it to the user or canister, and you could switch to a different gateway. And once this new project that we're starting, it's ready, this would all happen seamlessly without you even noticing. One thing that we haven't done yet is implementing Vetkeys, because they're not ready, or like ready, like production ready. But these would allow us to solve also the last problem, or the last attack that the gateway can perform, which is right now the gateway can read any message that it relays, of course. Vetkeys would solve this problem, and this is definitely something that we're going to do as soon as it's actually implemented and production ready. But just so that, just to make it clear, this sounds really bad right now, but node providers can already like read messages, because messages that the state of the canister is public, is not something that it's encrypted. Dfinity is of course working on it, but as of right now, we decided not to focus too much on making the WebSocket communication private, because it's like a guarantee that not even the base protocol, so the internet computer, can give.
Yep. Okay, I really like this conversation. Also, that you guys have clear plans for what's ahead. Already planning future features and improvements. Yeah, if you have anything to add, it's the time. We have a mentorship session in 3 minutes. And yeah, I'll see everyone at the mentorship session.
Just if you want to reach us out, I've sent the Discord, the IC WebSocket Discord link before, so you can reach us out there, or also on Twitter or on the forum or whatever you find us. Reach us out for anything. So yeah, really happy to talk with you and see what you're gonna build, especially with WebSockets.
Cool. Okay. Thank you, guys. Have a good afternoon.
Thanks, Seb. Thanks a
Thanks.
Bye,
lot.
everyone.
Bye bye.